This is the last video on the Eastern Cape September 2023 chemistry paper, and I'm on question 9.4, where we have the electrolysis of copper chloride set up. Now, they say that we have to write down the reaction that occurs at electrode B. The chloride ions, the anions, are attracted to the anode, and there is where oxidation will take place, which is a loss of electrons. So two chloride ions will form a chlorine molecule and release two electrons. So that is the answer to question 9.3. Now they tell us that 0.369 grams of copper is deposited at the cathode, so this is the cathode, in 27 minutes. And they ask us to calculate the electrical current used during this process, so the strength of the electric current. Now, to answer this question, we need to know that one copper ion will receive two electrons to form copper. And the mass that was given, we need to use to calculate the moles of copper that was deposited. So it's the mass of copper divided by its molar mass, which is 0.369 divided by 63.5, and that gives us 0.369 divided by 63.5. that gives us a 0.0058 mole of copper. Now, if that is the mole copper that was deposited, the mole electrons that was flowing in the circuit would be double that, because the ratio between copper and the electrons is 1 to 2. So the mole of the electrons doubles that, is 0.0116 mole. Now, electric current is the rate of flow of charge, and we've got 27 minutes that this charge is flowing. So the 27 minutes becomes 1620 seconds, and the charge on one electron is minus 1.6 times 10 to the minus 19 coulomb. So we need to know in this moles, in 0.0116 mole electrons, how many electrons were flowing. So the number of electrons would be the moles times Avogadro's number. So it's 0.0116 times 6,02 10 to the 23. Okay, so 0.0116 times 6,02 10 to the 23, and that gives us 6,9832 times 10 to the 21 electrons. And if that's the number of electrons that flowed, the charge that flowed would be the number of electrons times the charge on one electron, which is 6.9832 times 10 to the 21 times, and I'm going to ignore the negative charge on the electron, 1.6 times 10 to the negative 19. That would give us a charge of 1117.312 that flows in 1620 seconds, and that gives us a current strength of 0.69 amperes. Right, I hope you enjoyed and found the videos useful. Everything of the best for your preparation for final exams. Bye for now.